Hello guys, I hope you are doing well. Uh, in this video, we want to go to the tutorial question 1 of the lecture 2 of the fluid mechanics. First of all, we will go through the equations and review them, what we need in the first question. First of all, we have the mean density that, as you know, the mean density is the mass of our object over its volume. And the second equation is the relative density, that is the density of our material over a reference density, that mostly in our questions the reference material is water, that its density is equal to 1000 kilogram per meter cube. And the next concept is the buoyancy forces, that you know that the buoyancy forces try to keep our immersed or floated object in the liquid, or gases try to push it back up. But as you know, because the density of the gases is very low, we not consider the buoyancy forces in the gas, and we just consider it in the liquids. So in the formulation of the buoyancy forces, the rho is the density of our liquid, what our object is immersed in or floated on. So this is for the liquid, or I can say the fluids, not just the liquid. So let's say this is the density of the fluids. And what's the V? It's the volume of the displaced liquids. What does it mean? It depends on that our object is floated or immersed. If it's floated, just the part of our object which is immersed, it's our volume that should be considered. But if it's totally immersed, we should consider the whole volume of our object, which is immersed in the liquids. And so this part is a displaced liquid or fluid, and this is the g, or gravitational acceleration, that we know it's 9.81. So let's go to our question, which is a steel sphere for which the sigma is 7.8, has a diameter of 13 millimeters. We want to find out its mass, its weight in the air, and its weight in the water. So let's consider what the question gives us. We know that the relative density is sigma, which the formulation was that the sigma was the density over the density of water. So the density of our sphere, a steel sphere, is equal to sigma multiplied by density of water, which is 7.8 to 1000 is equal to 7,800 kilogram per meter cube. Please be aware of the units. It's important. So let's go through the diameter. The diameter here can lead us to the volume of our sphere. How much was is the volume of our sphere is equal to the V is equal to 4/3 pi the radius cube. So we know that the diameter is 30 millimeter, or be aware, you should use the length for meter, so you need to change it here. It's equal to 0.03 meter, but this is diameter. We need to have it to have the radius, which is equal to 0.015 meter. So our volume is equal to 4/3 pi 0.015 cube. I suggest you to use your own calculator to find out and be sure that how much would be the quantity of our volume. So I pause here and give you time in a second to find out how much is our volume. Okay, so our volume is 1.41 10⁻⁵, and the unit is meter cube. So refer to the equation of the density. The equation of density was mass over volume. So from these steps and these steps, we have the density, we have the volume, so we can calculate how much is the mass. So the mass is equal to density multiplied by the volume, which is 7,800 to 1.41 to 10⁻⁵. Again, please calculate it on your own way to be sure that you are in a correct way to calculate it. So I pause a moment to let you time. Please pause it and then go through it. Okay, it should be 0.1 kilogram. So this is our mass. Okay, so we found this part. Now we are going to find its weight in the air. As I told you, the buoyancy force in the gas is negligible. So the weight in the air is equal to mass to multiply by g. So it would be 0.1 to 9.81, which is 1.08, and the unit is Newton. Okay, so let's go through its way in a water. You know, when our object is in the water, first of all, think about it. It should be floated or it's immersed totally in the water. As our density is bigger than the density of the water, so it should be immersed. Okay, so because it's immersed, it comes down here. So it's fully immersed. So to calculate its weight, we should consider that in this case here, the weight is down. The buoyancy force is up. This is the buoyancy forces. So to calculate its weights in the water, we should subtract them. So the weight in the water is equal to the original weight minus the buoyancy force. Okay, let's find out. We know its weight. We need to calculate the buoyancy force. The buoyancy force was the rho of liquid, V of the immersed object, 2g. So the buoyancy force is equal to 1000. We have V here, and also we know G, which is equal to, I asked you to calculate it. Let me pause and calculate with you. It's 0.14 Newton. So the weight in the water with mass is equal to its weight in the air, which is 1.08 minus 0.14, which is equal to 0.94 Newton. Yes. That's all for the first tutorial. Please keep me subscribed for coming videos for the next tutorial questions. And if you have any questions, please let me know in the comments. And if you are interested in other topics, other lectures, please let me know in the comments. I try to make separate video for other lectures for you if you are interested. Okay, bye bye.